So in today's video, we are going to talk about the parallel combination of resistances. The Whenever the current is distributed among the resistances, we call it the parallel combination. As you can see in this diagram right here, the current is taken out from the cell, say of voltage V, and when it passes through the two resistances, it distributes into I1 and I2. So we know that I is equal to I1 plus I2. So now we'll see that how we can find out the R equivalent of these two resistors which are connected in parallel. So for the resistor R1, we know that the voltage across R1 and R2 is going to be the same because their two terminals are same. So uh, from Ohm's law, we can say that V is equal to R1 R1 times I1. So from here we get the value of I1 to be equal to V upon R1. Similarly, we'll get the value of I2 to be equal to V upon R2. So let this equation be equation 1 and this one be 2. So when we simplify these two equations and add these two, we'll get it to be I1 plus I2, which is going to be equal to V upon R1 plus V upon R2. So from this part of the equation we can take V common and shift it right here. And earlier we talked about the value of I1 plus I2, which was equal to I. So in place of I1 plus I2 we can write I, and divided by V is equal to 1 upon R1 plus 1 upon R2. And if we talk about the value of I upon V, we know that V upon I is equal to R, which is a constant from Ohm's law. So I upon V can be written as 1 upon R, and to simplify it a bit we can write R equivalent of the whole circuit, and which is equal to 1 upon R1 plus 1 upon R2. So now on simplifying we will get the value of R equivalent to be equal to R1 into R2 upon R1 plus R2. So we now have both of these equations and we can use them according to the questions that are asked. So this was an easy way of finding out the R equivalent of two resistors which are combined in parallel combination.